joining my session today. My name is Mohamed Wali. I'm working as a solutions architect for AWS Solutions Architecture team, based out of Amsterdam, the Netherlands, covering the Benelux region, which is Belgium, Netherlands, and Luxembourg. So it has been a heck of a flight for me so far, especially in the last 2 weeks. I was flying back and forth between the Netherlands and the US, so you can imagine to what extent I'm jet lagged. Yet I'm so excited to be here today in Sydney and in NDC conference in particular. Today I'm going to talk about Microsoft DevOps on AWS. But before getting started, I'm quite curious to know, is any of you familiar with Azure DevOps? All right, good to see. And has any of you used AWS before? Oh, that's great. Well, should be. And has any of you used Azure DevOps to build and release applications to AWS? All right. So I hope those who have used it before, there would be something new for you today. And for those who didn't, I will try to cover how we can establish the integration and how we can go through different scenarios for deployments, either for infrastructure as code or for building and releasing .NET applications from Azure DevOps to AWS. This is our agenda for today. Throughout this session, there will be plenty of demos for every single section. Some of them would be live, some would be pre-recorded for the sake of the time of the session, especially with the pipeline trying to build and test and publish and upload things here and there. It's quite hard to really do it live. So initially, I would be talking about AWS CloudFormation, what is it, how we can use it, how we can use Azure DevOps to deliver our infrastructure as code to AWS. Secondly, I would be walking you through building and releasing an ASP.NET web application to AWS Elastic Beanstalk. After that, I would be talking about how we can integrate AWS CodeDeploy together with Azure DevOps in order to do hybrid deployments for servers located in AWS as well as on-premises. Then we would be talking about how we can build and deploy containers at scale before covering how you can actually manage and retrieve your secrets from the .NET applications using AWS services. And last but not least, we would have some time to go through some Q&A. So over the last decade, AWS has been heavily investing into Microsoft tools and AWS. We're talking about API access tools, code construction, CI/CD solutions, and even domain-specific services. We are talking about tools such as AWS SDK for .NET and .NET Core, AWS tools for PowerShell, which would help you to create and manage AWS resources using PowerShell commandlets, AWS Toolkit for Visual Studio and Visual Studio Code, and AWS Toolkit for Azure DevOps, which we're going to talk about it today as well, plus the domain-specific SDK, such as X-Ray SDK for .NET, for Xamarin, for Unity, and so on. So today we'll be heavily focusing more on the AWS tools for PowerShell and the AWS Toolkit for Azure DevOps. What are the Azure DevOps services? Azure DevOps services are a bunch of services that would help you in your DevOps journey, starting from storing your code into source control using Azure repos, to building and releasing your code using Azure Pipeline, to creating your test cases using Azure Test Plans, till creating creating package feeds from private and public sources using Azure Artifacts. We do also have Extensions Marketplace, which extends the functionality of Azure DevOps by adding some tasks that you can use in your pipeline in order to integrate with third-party solutions. That includes AWS and other third-party solutions for Azure DevOps, such as SonarQube, HashiCorp, so on and so forth. Today, we'll be heavily focusing on Azure repos, Azure pipelines, and the Extensions Marketplace. So the first section is about how we can deploy our CloudFormation templates to Azure DevOps. But what's CloudFormation and how can I use it? So CloudFormation is AWS version of the infrastructure as code. It's mainly would help you to describe and create your infrastructure as code resources in a JSON or YAML format, so we can, solve the problem of is it JSON or YAML. It does support both, so feel free to use whatever you'd like. And it gets interpreted using the AWS CloudFormation engine that would deliver these templates into AWS resources stacks. That can help you so much, especially when the solutions gets complicated. If you are referring for enterprise solutions, for example, such as Microsoft SharePoint and the applications built on top of it, you can break them into layers and create CloudFormation stacks out of them, that would definitely help you to control the life cycle of your deployment for your solutions and deploy it with ease. Well, that's just an example, but we do have plenty of examples for ready-to-use solutions, not only for enterprise solutions, but also for small solutions. So if you're just getting started with AWS CloudFormation, have a look at AWS Quick Start. It has plenty of ready-to-use solutions, and it would be a good start for yourself. So how are we going to deploy the AWS CloudFormation to AWS using Azure DevOps? For that, we're going to use the AWS Toolkit for Azure DevOps, which is one of the extensions we're going to add from Azure DevOps Marketplace. This toolkit is owned and managed by AWS, and it has plenty of tasks that you can include in your pipeline that would help you in your processes, such as CloudFormation deployment, CloudFormation deletion, uploading objects to S3, uploading container images to ECR, so on and so forth. So you don't have to write the code yourself, the code that would help you to upload these images or create the CloudFormation template using Azure PowerShell or AWS CLI. So what we will be building today in the very first demo, we're going to have a simple VPC that would be provisioned with a couple of subnets in it. They would be stored in Azure repos, built and released using Azure pipelines, which would invoke the AWS CloudFormation API in order to deploy the VPC and the subnets to AWS environment. And with that, let's just go ahead right away to the Azure DevOps console and start the demo. So this is my repo where I'm storing the CloudFormation template for the VPC. I wonder if you can see it quite well, or do I need to zoom in? Feasible? All right. So I can also open it in Visual Studio Code. This is a CloudFormation template, just a simple VPC with a certain CIDR block tagged with a certain name. And within this VPC, I'm building a couple of subnets that are part of this VPC across different availability zones and tagged with a certain name as well. So what I'm going to do here for this repo, I'm just going to navigate to the pipelines in order to create the pipeline that would provision the CloudFormation to AWS. Over here, I'm going to click on Create Pipeline. And I do have two ways to create my pipeline. One of them is a new pipeline or the classic editor. Well, the new pipeline is not, I think it shouldn't be called new pipeline. It has been there for more than 2 years, maybe even 3 years by now. But they're still calling it new pipeline. But in this session, we're going to use the classic editor because the new pipeline is more about creating your pipeline configuration as code, which is something I highly recommend. It would help you the same way the infrastructure as code is helping you. But in order to dive deeper in the tasks we're going to use, I'm going to throw the classic editor to show you all the tasks and how we are configuring them. So by choosing the classic editor, you need to specify your source of your code. In this case, it's stored in Azure repos, selecting which team project, which repo, and which branch you would like to trigger the pipeline based on any modifications to it. In this case, I chose the main branch. Then when you click on Continue, you can choose any of the ready-to-use templates. For example, there are ready-to-use templates for .NET desktop applications, building and releasing them, the same for ASP.NET, Python packages, so on and so forth. Or you can choose YAML, which would get back you again to the new approach of the configuration as code pipeline, where you need to create the pipeline using YAML, or you can just start with an empty job, which is what we're going to do here today. In the empty job, we need to specify the following properties: the name, the agent pool, and the agent specification. So the agent pools, there are two types of agent pools. There is the managed agent pool, and there is the self-managed agent pool. The managed agent pool is a pool of agents provided to you by Azure. So it's fully managed by them. You don't have to worry about cleaning up the build agent. You don't have to worry about having a dedicated server to do the build processes. And the self-managed one, in this case, you need to download the Azure DevOps agent yourself, install it in one of your servers, and you can use it to build and release your jobs. So throughout the demos we're going to have today, I would be using both of them. In this demo, for example, I'm going to use the managed agent pool, in this case, the Azure Pipelines one. And when it comes to the agent specification, I can choose which operating system I would like to use for my agent. And over here on the agent job, you need to give your job a decent descriptive name. Let's say simple VPC deployment. And then you need to start adding the tasks that will run within the job. So initially, before getting started by adding the tasks, we need to add the AWS toolkit for Azure DevOps. So if we navigate to the marketplace section over here and search for AWS toolkit, we should be able to see that we can able to retrieve this this extension, and we should install it. In order to install it, if it's not installed in your organization already, it would tell you get it free, so you need to click on it and walk through with the wizard or the console, which is very straightforward. All you need to identify is which organization you would like to install the extension into, and that should be it. It just takes 2 or 3 minutes to get provision. And once it is installed into your Azure DevOps organization, you need to go back again here for the tasks and start to search for the AWS task you would like to achieve or deliver. In this case, it's CloudFormation. So what I would like to do is I would like to create or update a CloudFormation stack. So in this stack, I need to give it a name. It's VPC deployment, just any descriptive name. Then I need to specify AWS credentials. These credentials would be used in order to access AWS environment and do the deployment. Because by the end of the day, if I can just write my code and I would like to deploy it to my environment, it needs to know which environment it's going to deploy to. So in order to create these credentials, I can either click on New and fill the fields, or I can navigate to Manage, where I would be redirected to the service connection page. In this page, you can create a new service connection where you can select the service or the connection type. In this case, it's AWS. Then you click on Next, and you need to specify the access key ID, the secret access key, and just give a description name for your service connection. You can optionally actually add some rule to assume. For example, if you do have multiple projects, and every project has its own set of permissions needed in order to do the delivery. For example, if you're using CloudFormation here, in order to provision a VPC, you need to have the IAM permissions to create and update the CloudFormation stack, but you also need the permissions to create and modify a VPC. So if you'd like to really restrict this permission, you can actually create a rule with the right permissions and add it here to be assumed. Once done, you need to make sure that the grant access permission to all pipelines is checked, so it would be visible for your pipeline. Once done, you can click on Save. This is the one we're going to use today. If I just edit it, these are the information I have passed to it. Pretty much the same I have discussed in the example, and it's very straightforward. Once it's created and saved, you can select your credentials from here. Then you need to specify a region. In this case, it's Sydney, and you need to specify a CloudFormation stack name. Let's call it simple VPC deployment. Then you need to specify your template source. Where is your template stored? It could be stored in a local file. With a local file here, it refers to the local place of your repo. In this case, we're using Azure Repo, so it needs to be stored in our repo. But you can also upload a URL, specify a URL for the template file. Maybe you have uploaded it in an S3 bucket, and you'd like to use it right away from there instead of keeping it in Azure Repo. Or if you are storing it in a private S3 bucket, maybe you can choose this option since it's not publicly exposed. But the connection here that you have specified for the AWS credentials need to have access to this S3 bucket in order to retrieve the CloudFormation template. Then you need to specify the template name and the object key. Or if it has been already provisioned before using Azure DevOps, you can use previous template. In this demo, I'm going to go for the local file one, and then I'm going to explore my repo, select the CloudFormation template. And on the section of the S3 bucket, if you would like to upload this template during the implementation to an S3 bucket, you can define the S3 bucket over here, and it would be uploaded right away. In case you do have some parameters stored in a separate file other than the CloudFormation template, which is I highly recommend, especially if you do have multiple environments to which you're going to provision the same resources but with different values. So create a dedicated parameter file from which you can use for the different environment and the different deployments. But for the sake of this demo, we don't have any. It's quite simple, so we are not going to specify any parameters file. The capabilities to be checked, the normal ones for CloudFormation is to give the CloudFormation the permissions to, or the authorization to create or update any IAM resources or named IAM resources in case this template is going to create any IAM-related resources or update any of them. What would you like to do in failure? You can choose the options from here, either to roll back, do nothing, or delete the whole CloudFormation template. And once you're done, you can save and queue. But before saving and queuing to start the deployment, I would like to walk you through this trigger section where you can actually enable continuous integration for your pipeline. So the next time you commit or push something to a certain branch in your repo, this pipeline would run automatically. I highly encourage doing it for lower environments, but you need to be working carefully when it comes to higher environments, because by the end of the day, not with every commit to your repo, you would like your pipeline to be triggered. But in this case, I'm going to enable continuous integration so for the main branch. So when I try to push a new update for my CloudFormation template, the pipeline would run automatically. Now I can actually just go ahead, save, and queue. Give it a comment. Let's call it initial deployment. I don't want to change any other properties, and save and run. Once the pipeline is triggered, it would start to try to find an available agent in order to run the build process. So at this stage, it's trying to find any available agent it can use. It managed to find one. Now it's checking out and trying to create or update the CloudFormation stack. So if I navigate it to the CloudFormation console, try to refresh it, as you say, there is a create in progress going on for a CloudFormation template. I can track from here for the VPC deployment the events on where it's going, what has been provisioned so far, what's in progress. And as you say, the VPC has been created. The public subnets are completed as well. That's actually great. So if I navigate it back again to my pipeline, I can see that it has finished, and now it's wrapping up. So with that, we managed to deploy an AWS CloudFormation template to AWS using Azure DevOps. But what if I would like to update my CloudFormation template? So what I can do over here, I would like to just add a new subnet to my VPC using the CloudFormation YAML code. I'm going to change just some naming conventions and CIDR block. The availability zones would be used, the tag. Then I'm going to push and commit, adding another subnet. And I will commit and push. And once it's ported, it should trigger the pipeline automatically. So if I navigate back to the pipeline over here, I can see that a new deployment has started. So if I track the deployment, it's still at the stage of trying to find an empty agent. Well, it did. And now it should be updating the CloudFormation template. The update is going on progress for the time being, which means it managed to detect the latest status of my infrastructure deployment and just added that part of the update. It didn't create a new deployment. It didn't conflict with it. So if I keep refreshing, I would manage to see that the update has been completed successfully. And if I went back to my pipeline, I see that it's wrapping up. It's just waiting to ping it back to indicate that the deployment has went successfully. And yes, now it's wrapping up, and voila. With that, we have seen actually how we can deploy an AWS CloudFormation template, update the CloudFormation template from Azure DevOps pipeline. In case you do have any questions, since we'll be moving from one demo to another, please feel free to raise your hand and ask me right away. Yeah?
Is there any warnings if you're removing?
Moving anything?
You'd be able to remove a subnet to get a warning?
Well, if you're removing a subnet out of it, no. In this simple pipeline, you will not. But what you can do is you can add some test cases. There are some test solutions that can help you to test your infrastructure as code the same way you're doing with your .NET code or any other code. But no, it wouldn't notify like, hey, it's going to remove this. Would you like to proceed? That's not going to happen. That's why we tend to test our solutions in lower environments as well, to make sure that everything went well before promoting to production. But if you would really like to restrict the access, there are some test solutions who can help you with that. Any other questions? All right. So Azure DevOps is although we do provide a toolkit for Azure DevOps, which simplify the deployment for our AWS resources, but you still can use definitely any other CI/CD solution. It shouldn't be a problem. In fact, you can use Jenkins, Bamboo, or any other CI/CD solution. There would be no toolkit like the one we saw, but you can use AWS CLI and AWS tools for Windows PowerShell in order to trigger whatever resource you would like. You can trigger your CloudFormation template using AWS CLI or AWS tools for PowerShell as well. I'll show you later actually how we can customize our pipeline and how we can use PowerShell, for example, in order to run some certain AWS tasks instead of using the AWS toolkit. So the second section is about AWS Elastic Beanstalk deployment using Azure DevOps. What we're going to do here is we're going to build an ASP.NET web application and deploy it to an AWS Elastic Beanstalk using Azure DevOps. Is any of you familiar with Elastic Beanstalk? Has any of you used it? All right, that's good to see. So Elastic Beanstalk is an AWS managed service that simply helps you to remove the operational burden of managing the underlying infrastructure for your EC2 instances, including operating system, auto-scaling, your web server part, and let you focus more on writing and delivering your code. It does support multiple platforms. It does support .NET, Java, Python, Go, Docker, Node, so on and so forth. But in case it doesn't support a certain platform, or in case you want it to be bootstrapped with a certain sidecar or a certain library which are not provided with the default AMIs, you can bake your own Amazon image yourself, install whatever you would like to have it there, and use it for Elastic Beanstalk. So what we will be building today, we will be building an ASP.NET web application, storing it in Azure repos, building and releasing it using Azure pipelines with the help of build agent. The build agent here is a self-managed build agent. So in this demo, there is a build agent that has been already installed in an EC2 instance, and an instance profile has been attached to this EC2 instance with the needed permission. So you really restrict the access or the permission that this EC2 instance or the build agent can use from this EC2 instance. So this build agent would build your package, archive it, then upload it to an S3 bucket, and then invoke an AWS Elastic Beanstalk API, which would retrieve the package of the application and install it accordingly. So our demo today is called My Tiger App. It's a very simple, teeny tiny ASP.NET web application. As you see here, this is our environment. We do have two environments for our application hosted in Elastic Beanstalk, one on dev and one in production. They are installed both on iOS 10 and Windows Server 2016. They are both healthy and green, which is always good to see. If I open the web application, well, it seems to be accessible. It seems to be working fine. This is version 1 of the application. So whenever we get back to it later and modify it, we can notice the difference. So this is a pipeline for the development environment. It started with the typical .NET Core build activities that we tend to use, starting from restoring the nuggets, building, testing the application, publishing the package. And afterwards, it would start to copy the Elastic Beanstalk manifest file. The manifest file is a descriptive file for what you would like to do, what you would like to achieve in your deployment. As you see here, you're specifying your application bundle, the iOS path, and the iOS website. In this case, it is a default website. And by specifying these, you have this kind of descriptive for what you would like to achieve. And then you can, the task that would be used to copy it to the staging directory. So we can use it in the next step in order to zip that file from the staging directory and move to the next step, which would upload it to an S3 bucket, which would be used later when we invoke the Elastic Beanstalk API in order to retrieve this bundle and install it on the right environment. As you see here, we are specifying the region, the application name, the environment name, and the deployment bundle type. This is a way for using the AWS toolkit, but we do have another pipeline that's doing pretty much the same, but in a custom way. It's using PowerShell instead. So the same initial steps we do have here, starting from restoring till creating a zip file for the package, no difference, pretty much the same steps we have done on the previous pipeline. The difference is actually in the last two steps, which is about uploading the package build to S3 and to trigger the deployment against Elastic Beanstalk. So over here, as you see, this is just a partial commandlet for uploading the S3, the object type, the object we have zipped to an S3 bucket. And the next step would be invoking the Elastic Beanstalk API, which would actually use the Elastic Beanstalk deployment PowerShell script, where you do have to specify certain arguments like the application name, environment name, build number, so on and so forth. This is our application code. As you see, it's quite simple, actually. I'm just going to do teeny tiny changes for it so we can see the changes when our pipeline runs, changing it to version 2, specifying which pipeline it would run it. In this case, it is a partial pipeline, which is the customized one, not the one using AWS Toolkit. Then committing and pushing it to Azure repos by just writing a simple commit message and then pushing it accordingly. So once the application is pushed, the pipeline would run. Since we have enabled continuous integration for it, it would go through the steps we have identified in the pipeline. Since I'm using video recording, things seems to be going quite fast, but it really doesn't look like that in real life. And at the stage of the deployment part, it's now invoking the API of Elastic Beanstalk to start the deployment. It would start to build, since this is a normal deployment, it would put the environment I'm deploying to, which is dev environment in Elastic Beanstalk, in gray, so it wouldn't be healthy, as you see here, just due to the deployment that's going on. But you can definitely change the deployment type you wish. It could be a rolling deployment, whatever you would like to have eventually, that's going to fulfill your needs. And since for the time being, the deployment is going on, it's trying to copy the files, install the application, restart the IIS services to make everything up and running. And now its health has turned to green, and I can now navigate to the application, and it seems that the deployment has went successfully, which what we was definitely looking for. So with that in place, normally what I do recommend is once you have your application in dev environment, you might be interested to promote it to production. For that, we can use the swap environment URL, which is a feature that would help you to swap both environments, where after testing, of course, your deployment, if everything went fine, you can promote your deployment to dev environment, from dev environment to production, and from there, you can access your deployment to the higher environment. Once it's swapped, if we opened it here, you would see that the application that's running here is a dev application. And what we would like to do next, in case we got any problems, we would like to clone the environment. Nobody would like to troubleshoot in production. So you can clone in this environment if it has any problems. Cloning it is pretty straightforward, as you see. And once it's cloned, you can start your troubleshooting just to avoid any hassle of testing or troubleshooting your application in production. Nobody wants to do it by the end of the day. Once the clone is done, it should turn into green as well, and you should be able to start interacting with it. With that, we can actually wrap up our second demo for how we can use Azure DevOps to deploy your application to AWS Elastic Beanstalk. Any questions? All right, so the next section is about how we can use AWS CodeDeploy together with Azure DevOps in order to do hybrid deployments. For example, if you do have servers on AWS, if you do have servers on premises, that's what we're going to cover today in our demo. But actually, this demo can be extended way beyond. If you do have servers on any other cloud platform or any other hosting provider, as long as you'll be able to install the CodeDeploy agent on the server, you should be able to trigger a deployment against it. So what we'll be building today, so we're going to have two EC2 instances acting as our cloud servers, and my local laptop, which would be acting as my on-premises server, and install the CodeDeploy agent on all of them, and create a deployment group for them in AWS CodeDeploy called preprod. We're going to have our console app in Visual Studio Code, which would be stored in Azure repos, built and released using Azure pipelines, with the help of the build agent that I covered in the previous section. This is pretty much the same agent I'm using here and the very same one I'm using in the next demos as well. And from here, we're going to build the application and release it or upload it to S3 bucket. And once it's uploaded to S3 bucket, we're going to invoke the AWS CodeDeploy API, which would start installing the applications onto the servers we do have as part of the pre-prod deployment group and update the application environment accordingly. So when it comes to CodeDeploy, you can deploy your configuration in different ways. You can deploy all of them all at once. You can deploy one at a time. You can customize it the way you wish. Just for the sake of the demo, we're going to deploy all of them all at once. So feel free to choose a deployment method that fulfill your needs and meets your organization requirements. So how it's going behind the scenes, how actually CodeDeploy is going to install the applications onto these servers. So we create an app spec file. It's a YAML file where you need to specify the operating system of the servers on which you're going to install this application. You need to specify the files that would be copied and pasted. What is the source? What is the destination? You can specify some lifecycle events using the hooks as well. Like, what would you like to do before installation? Would you like to stop a certain service? Or what would you like to do after installation? Would you like to restart a certain server? So all of that can be controlled using the app spec file. So our app in this demo is my Donkey app, which is still pretty much a very simple application that we're going to use. As you see here in the demo, these are two EC2 instances that would be used as the cloud servers in this case. They are both tagged with a tag called env preprod. This would be the tag we're going to use to filter based upon to enroll them into our deployment group. So if we navigate to the AWS CodeDeploy console under the application, I have created already an application called my Donkey app-test for the compute platform of both EC2 and on-premises. If I open this application, I do have two deployment groups. The one I'm going to use for the demo today is my hybrid environment. That's where I'm adding my instances to be used. So if I scroll down, you can see that I'm filtering which servers I would like to include as part of this deployment group for both on-premises instances and EC2 instances based on the tag of env preprod. So any EC2 instance with that tag would be automatically retrieved, the same for on-premises. On the on-premises instances, there is none now since I need to install the CodeDeploy agent, and so I would be able to see it. I have downloaded and installed the CodeDeploy agent on the local laptop. I'm verifying that the CodeDeploy service is running now. Installing the CodeDeploy agent is very straightforward, just making sure the service is running and logged in as the local user account. So, well, in the deployment, I was just checking the estimate charge remaining, just to make sure that the battery is not running out of, the laptop is not running out of battery. And then I start to retrieve the AWS credential profile, which is a CodeDeploy setup profile that I have created beforehand with the right permissions needed to register this server, in this case my laptop, against CodeDeploy. Well, the rest of the commands I'm using here is pretty much the ones you can actually do with AWS CLI using AWS configure, where you are identifying the profile, where you are identifying which region. Then I need to register the CodeDeploy agent by register-cd on-premise instance, specify an instance name, and specify an IAM user ARN. This ARN should be an ARN of an IAM user that has enough permission to retrieve the application from the S3 bucket. So I gave it an S3 read-only access, which is actually needed by this laptop in order to be able to retrieve and install the bundle. So once it's registered, I can navigate back to the AWS CodeDeploy console for the on-premises instance. As you see here now, we can see the laptop registered, and it seems to be accessible, but it's not tagged yet, so we need to add the tags. We need to create the env preprod tag, so it would be retrieved to be a part of the deployment group of AWS CodeDeploy. Once we have done that, it should be already there. So this is our teeny tiny application that we're using. It's a very simple one that writes a line called donkey ate a mango, but we do also have an app spec YAML file. That's where we are identifying what we would like to, which operating system we're using for our servers, what are the files we would like to copy from where to where, if we would like to do any life cycle events, as mentioned earlier, such as would I like to do something before installation, after installation. These are the scripts that would run before and after the installation, and just doing some basic stuff like creating a folder, and the other one is creating, after the installation, creating some file within that folder that gets created, just for the sake of the demo. So this is a pipeline used in order to build and release this application. It's very simple as well, using the very common, very normal .NET build tasks, restoring, building, and testing. And the next step after building and packaging the application is to copy the files used, the PowerShell script files, to the staging directory so we can actually archive them and upload them afterwards to the S3 bucket. That would be from which we can retrieve the application later on. So we are uploading them using this task and invoking the CodeDeploy API using this task as well, where we are specifying the region, the application name, and the deployment group name. And once specified, if you scroll down, you can see that we can also specify other properties, such as the S3 bucket name, what is the revision bundle key in this bucket, and so on. So if I navigate back to the application, just to do a minor change to see how the pipeline would interact with that, I'm going to change it to donkey ate an apple instead of donkey ate a mango, like a donkey can eat them. And then I'm going to commit my change and push it to Azure repos. And once the change is done, once it's actually pushed to Azure repo, like the previous pipelines, it would trigger the pipeline automatically. So now if I navigate to the pipeline, I can see it has already started. Now it's running. Managed to find an agent. Going through the build steps we have identified in the pipeline. And once it has gone through these steps, it will start to upload the file. And now it's deploying the package to the right servers on which we have installed the agent using CodeDeploy. So if I navigate to the deployment section under CodeDeploy in the CodeDeploy console, I can see that the deployment is going on. It actually managed to install it so far for 2 servers out of the 3 servers. The deployment is still going on progress for the 3rd instance. And if I scroll down a bit, I'll be able also to see the status of the deployment for which servers. Like as you see here, 2 servers, which is clearly the EC2 instances. The deployment has went successfully for them. It's still doing it for the local laptop. And now, by fast forwarding, the deployment seems to have gone quite successfully. If I scroll down, I can see that the application deployment has been succeed so far, which is always good to see. And now we can test if our deployment went well or not by just running a .NET command to for the DLL to say if it has changed or not. Clearly, it has changed it to donkey ate an apple, which what we were looking forward to say. With that, I'm wrapping up the second demo of using CodeDeploy together with Azure DevOps. If you do have any questions about that section, please shoot. All right. So the next section is about how we can deploy containers at scale using Azure DevOps. So AWS offers you a variety of container orchestration solutions. We are talking about Amazon Elastic Container Service for Kubernetes that offers you a managed Kubernetes service on AWS. The same for the ECS solution, which is Elastic Container Service. It's an Amazon proprietary. It helps you to manage your application. It offers you a seamless integration with other AWS services. There is also AWS Fargate, which is kind of a serverless version of the container services we do have, where you don't have to worry at all about the underlying infrastructure used, either for Kubernetes, the EKS, or the ECS. You can store your images in the ECR, which is pretty much similar to Docker Hub, and can seamlessly, of course, integrate with other AWS services. In this demo, we're going to use AWS Fargate together with the ECR. So what we'll be building, we're going to build an AWS Fargate ECS cluster, where we're going to create a service thread. Behind it, there will be 2 containers. These containers would be targeted by an elastic load balancing that would expose the solution to the public and the end users. So the application is an ASP.NET Core web application stored in Azure repos, built using Azure pipelines with the help of the build agent we used before. And this build agent would be building the image of the application, pushing and uploading it to the Amazon ACR. And once it's stored there, it would invoke the service API of the AWS Fargate in order to deploy a new version of the containers, which would be actually added as targets as well for the elastic load balancing. And at this stage, the load balancing would be able to show both the old deployment and the new deployment until it starts to drain the connections for the old deployment and keep only the new deployment. And afterwards, we'll just decommission it. So with that, let's see actually how my Wolf app is getting deployed. This is my application. I do have here an AWS Fargate ECS cluster up and running. It has one service, which is a service I referred to earlier, with 2 tasks running. So this is the service. It's called my Wolf website. It's active. It has 2 desired tasks and 2 running tasks. So if I navigate to the tasks, I can see the tasks over here. And their status seems to be running, which is always good to see. So if I navigate back to my service, I can also verify if the desired count is equivalent to the running count or not. The only case that they might not be equivalent if there is a problem with one of your containers, or if you have a minimum requirement, then like the minimum target is less than the desired count. These are the registered targets, which are the containers. They both have their own private IP addresses. Their status is healthy, and this is a load balancer they are registered behind. So what we're going to do now is we're going to navigate to the URL of the load balancer, and that's where we can see that the application is up and running. If we refresh the application, we can see that it's round-robining between the 2 containers, displaying the different IP address of every container whenever it redirects traffic to one of them. So as you see, it's up and running. It's healthy. This is our ACR repository where we are storing our image. So these are previous versions of the image we are using. The latest image to be used is this one. Whenever an image is being pushed to the ACR, it's tagged with latest, so it would be used by the service right away. This is our pipeline. It starts with the typical .NET Core build activity steps that we have gone through earlier. The next 3 activities are custom-made ones using command line instead of using AWS toolkit tasks. The first one, it's building the Docker image using Docker build. The second step is to publish this Docker image to ACR by just running, by just logging into the ACR repo and then tagging it, and afterwards start to push it to ACR based on that. So once we are done with the build process, with the publish process to ACR, we can now invoke the AWS Fargate service using AWS CLI as well in order to update the service to use the new Docker image and to update our deployment accordingly. So this is our application, very simple application as well, called my Wolf app. I'm going to do minor modifications for it. I'm going to name it Welcome to Fargate, change the version, just to be able to reflect the changes we are doing for this application. And once we are done with our changes, we can actually start to commit and push it like we did in order to push it to the repo in Azure repos. So once I'm pushing it, I need to pass a username and password because in this demo, the Git credentials were not configured already, but normally they are there. And once I pass the username and password, which are the Git credentials, it gets pushed, and I should be able to say that the pipeline gets triggered. So a new pipeline has been triggered, and I can track from there the deployment progress of my solution. So at this stage, it's trying to build the Docker image. Once it would manage to successfully build this Docker image, it would proceed to the next step, which is actually about publishing it to ACR. I've shown you the commands used so far. Once it's published to ACR, well, as you see here also, it managed to detect that it already has some layer exists because this image was already there. What it's doing now, it's just a minor or a delta change for the application that was already there. So once it's done with the publish process of the application, it will just invoke the service API right away, and now we can navigate back to AWS console to see how our AWS Fargate service is behaving. And as you see, if I refresh it now, we do have both the old deployment and the new deployment. It's just the old deployment is still up and running and healthy. The new deployment is still trying to ramp up. If I went to the web page of the application, it's still displaying the old version. My application is still at this stage where it still needs to ramp up. Once the deployment starts, it will be put into a bending state. And from there, it would start to be put into a running state where it would need to install and use anything defined for it in the ECR image. So far, if I keep refreshing, it's still, both of the deployments are still there. How long it does take depends on the size of the application, but at this stage, it managed to view the old containers and the new containers behind the load balancer. So this is the stage we see both of them. The new containers are still trying to initialize, but if I went to the web page and keep refreshing, I can see that it keeps redirecting me to both the old version and the new version, because this is a stage it has both of the applications or both of the deployments up and running. And once it's done with, or once the new deployment is up and running, ready and steady, properly initialized, it will start to drain the connections of the previous deployment via the load balancer. So if we keep refreshing, now it starts to drain them in order to stop the connections to the old containers. And once these containers are drained, it would start to decommission them. So now if I keep refreshing the page, it just keeps load balancing between the two new containers, showing the new version, and just round-robining between the different IPs of them. And with that, we actually did manage to deploy our containers without pretty much any problems using Azure DevOps. So please let me know if you do have any questions about that section. All right, so moving next to managing secrets, which is the last part of the session. So you're going to build your .NET application, and you're going to definitely need secrets. These secrets could be connection strings, could be database usernames and passwords, could be API token, could be anything. At AWS, you can use AWS Systems Manager, Parameter Store, Secure Strings, or you can use AWS Secrets Manager. Well, normally, I tend to recommend Secrets Manager just because Secrets Manager offers extra functionalities, such as it would help you to rotate your secrets. It gives you a more capacity for a bigger secret if you would like, so you wouldn't have hit any limitation. But on the other side, AWS Secrets Manager is slightly more expensive than the Parameter Store. In fact, the storage of Parameter Store is for free. What you get charged in for in Parameter Store is how many times you are retrieving secrets out of it. So which solution would like to use? Make up your mind depending on your need. If cost is a concern for you, if you think Parameter Store should be all right to use, just go ahead with it. Otherwise, you can use Secrets Manager. This is an example of what kind of IAM policy you need to attach for whatever the service you are using in order to retrieve the secret. This is an example for how you can retrieve a certain secret or restrict the access to a certain secret while also allowing a KMS to decrypt. So when it comes to Parameter Store secret strings, they got encrypted with KMS. So whenever you would like to retrieve them, you need to have the permission to describe the parameter, but also the permission to decrypt the secret using KMS, the KMS encryption key that encrypted it. The same pretty much in AWS Secrets Manager. Just make sure that you are attaching the right policy, restrict the access as much as you can, and assign it either to an IAM rule your script temporarily assumes, if it's just a script you run locally or anywhere, or if it's an IAM user that's testing it, or definitely if it's an instance profile or tasks rule, if it's an EC2 instance or a Fargate task. These are just examples for how we can retrieve the secrets, either for using PowerShell for AWS Systems Manager, Parameter Store, or Secrets Manager, or for using .NET. The second option for Secrets Manager, it's available to use. Once you create your Secrets Manager, you can just navigate to the section beneath it in order to view which language you're using and copy this code, include it into your code. And the other one, as a Parameter Store, you need to make sure that you do have the Amazon Simple System Management Client installed in order to be able to run it. And with that, We are hitting a wrap up for our session so far. So my key takeaways of the session: utilize the available tasks in AWS Toolkit extension. They are meant to help you to avoid wasting time in creating or writing the code for every single task you'd like to achieve. All you need to specify for them are just few properties that would tell you or illustrate or elaborate for them what they need to do next. Use build your own custom tasks whenever needed, because by the end of the day, although AWS owns and manages the AWS Toolkit for Azure DevOps, but it doesn't necessarily support all of the AWS services and definitely doesn't support all the tasks. So you might hit a limitation at some point. So at this stage, you can use AWS CLI or AWS partial tools, as I have shown you earlier, in order to create your custom task. Use both managed and self-managed build agents whenever needed. Managed agents, as mentioned, they're definitely going to help you in reducing the headache of focusing on installing the agent, maintaining the server on which this agent is installed, cleaning up the agent because of the build processes that's going on. But also at some stages you might need it. If you do have a sensitive application, for example, where you don't want to build it on top of Azure pipelines, well, for that you can use actually a self-managed build agent. Utilize the integration between Azure DevOps and AWS DevOps tools to go hybrid, as I showed earlier in the scenario of integrating Azure DevOps together with AWS CodeDeploy. Actually, that can be also extended to integrate with AWS Code Pipeline, with AWS Code Build. So feel free to integrate them with these services, especially if you think that it's going to provide you a seamless integration with another AWS service. Store your secrets wisely. And that depends on which solution you're going to use, secrets manager or parameter store, which option you're going to for is very dependent on your case. But as mentioned, everyone has pros and cons. Secrets manager is definitely more mature, more relevant to storing secrets, but slightly more expensive than parameter store. That said, I would be more than happy to hear any questions.
For the secret manager, I think the example you had was DB password. How would you cater for the idea that you want one password for production and another password for dev, but it's still the same secret? Can it be the same secret?
No, it doesn't necessarily. So the question is, how can I promote it for multiple environments, for example, using the same code while differentiating the different secrets between an environment and another, right? So in this case, you need to create multiple secrets, one secret for every environment, and you can parameterize this part in your code, so you can pass it during your deployment, like which one to grab and which one to pick up. That's going to help you in that. But definitely, it's not recommended to use the same secret for different environments. That's totally against security standards. Any other questions? All right, I would like to thank you, Zim, for joining my session today. I wish you a lovely day ahead. Thank you so much, and have a nice day.